State and explain the effect temperature has on equilibrium position and Kc. So endothermic means if I have a reaction, if I have A plus B yields AB, and I tell you that delta H is a positive value, then that means that heat must go into this reaction to help the reactants form product. So we say this is an endothermic reaction. That's for the forward reaction. But if we look at the reverse reaction, AB needs to lose heat or release heat to break back down into the reactant. So this is why Kc will be affected by temperature, because heat is always going to affect one side, one direction of the reaction in a positive way, and it's going to affect the other in a negative way. So the changes aren't going to balance out. So if I have an endothermic reaction, my reactants need that heat to form product, and then once the product forms, the product can't revert back to the reactant because it needs to get rid of heat, and I'm adding heat. So it's only a one-directional change, as opposed to when you add just more concentration of a reactant. Now when it forms product, that product can break back down. But the heat is preventing the new additional product from breaking down, so it's going to drive Kc up. So when I add heat to an endothermic reaction, I get more collisions on this reactant side. I form more product, but that product is unable to break back down into reactant. So I see several changes. I see an increase in my yield. I see my equilibrium shift to the right, and I also see Kc increase because I've got more product and I'm removing reactant. If I remove heat for an endothermic reaction, now my reactants can't collide as successfully, but my products can collide more successfully because they need the heat to be removed. So now I see the opposite shift. I see more product colliding successfully and forming reactant, and my equilibrium shifts left. It's also going to decrease or increase Kc. No, it's going to decrease Kc because I'm shifting left. So as my product decreases and my reactant increases, I'm going to see an increase in Kc because, again, as reactant forms, unlike adding a product substance, my reactants can't break back down because they're losing heat and they need that heat in order to form product. So exothermic, we're going to see the reverse thing going on. So with my reaction down here, exothermic means a lower temperature is good, like in my example down here. So the negative H is telling me that to increase yield, I should decrease the temperature. And then that would affect my Kc. Looking at Kc a little more, again, the reason Kc changes with temperature changes is because the change in collisions only goes one direction. Changing the temperature only favors one reaction, either the forward or the reverse, but not both. So an endothermic reaction will have more successful reactant collisions, but the product will not be able to revert back at the higher temperature. And to predict the effect on Kc, if temperature moves the equilibrium to the right, then there's more product, so Kc increases because Kc is always a ratio of product to reactant. But if temperature moves equilibrium to the left, then Kc is going to decrease because now you've increased your reactant and decreased your product, so the ratio will drop.